You know every app you use, every game you play, every single website you visit? What if I told you they're all built on a secret language? A language made of just a handful of simple symbols that tell our entire digital world exactly what to do. Well, today we're going to learn that language. I mean, have you ever really stopped to think about it? How does your phone know your password is correct? Or when you're playing a game, what's actually happening under the hood when you level up? It feels like some kind of digital magic, right?
Well, it turns out it's not magic at all. The answer is actually pretty simple. It all boils down to a small set of symbols we call operators. These little guys are the secret language of all code, and once you understand them, you unlock how pretty much all software works.
So, where do we start? Well, we start exactly where computers start, with basic math. Before a computer is anything else, it's just a ridiculously fast, super obedient calculator.
And these symbols should look really familiar. I mean, it's just addition, subtraction, multiplication, and division. We all learn this stuff in elementary school. And at its very core, this is what a computer does best. It just crunches numbers using these basic operators, but millions of times faster than we ever could.
But here's one you might not know from math class, the modulo operator. It's that percent sign. This one is super useful. See, it doesn't care about the answer to a division problem, it only cares about what's left over. So 7 divided by 3 is 2, with a remainder of 1. Well, 7 times modulo 3 just gives you that 1. It's a neat trick for things like figuring out if a number is even or odd.
Okay, so a computer can do math. Awesome. But what's the point if it can't even remember the answer? That brings us to our next huge building block, memory.
Now you gotta pay close attention here, because this is so important. We all see an equal sign, and our brain immediately thinks these two things are the same. In programming, you have to unlearn that habit. A single equal sign isn't a question, it's a command. It means, hey, take the value on the right and store it in the box I named on the left. This is the assignment operator, and it's how a computer remembers everything, from your username to your score in a game.
All right, so our computer can do math, and it can remember the answers. We're getting somewhere. But the real magic, the thing that makes software feel smart, is when we teach it how to compare things and make simple decisions.
And this leads us to one of the biggest mix-ups for anyone starting out. If a single equal sign is a command to store a value, how do we ask if two things are already equal? Easy. We use a double equal sign. Just remember this. 1 equals is a command, 2 equals is a question.
And this whole question-asking thing goes way beyond just, are they equal? We can ask if they're not equal, if one thing is bigger than another or smaller. These are our comparison operators, and they are the absolute heart of all decision-making in code.
So when we ask the computer a question like, hey, is 10 greater than 5? It doesn't give some complicated answer. Its world is totally black and white. It only knows 2 words, true or false. And that simple yes or no logic is the foundation for every complex decision a program ever makes.
But, you know, asking just one true or false question at a time is pretty limited, right? You can't run an entire app like that. The real power comes when we start combining these simple questions to make more sophisticated rules. So let's make this real. Think about something we all do a million times. Logging into an app. The computer needs to ask, is the username correct? That's one question. Then it needs to ask, is the password correct? That's a second question. So how does it combine those 2 answers to make one final decision?
This is where logical operators come in. The computer checks the first part. Is the username correct? Let's say, yes, that's true. Then it checks the second part. Is the password correct? Okay, that's also true. Only because the first part and the second part are both true does it grant you access. If even one of those was false, it'd be access denied.
And that's really the core of it. The AND operator is the strict one. It demands both sides be true. The OR operator is way more chill. It just needs at least one side to be true. And then there's NOT, which just flips the answer. It turns a true into a false and a false into a true. With just these 3, you can build basically any logical rule you can dream up.
So we have all our building blocks. We've got our math, our memory, our comparisons, our logic. But what happens when you throw them all together in one big messy line of code? How does the computer know what to do first? Well, just like any language has grammar, code has a rule book.
Okay, quick pop quiz. Take a look at this problem on the screen. 10 minus 2 times 4. How would you solve that? Because depending on the order you do it in, you can get 2 totally different answers. So, which one is it?
Now, your first instinct is probably just to go from left to right. You do 10 minus 2, which is 8, and then you take that 8 and multiply it by 4, and you get 32. Seems perfectly logical, right? Well, it's wrong. The correct answer is actually 2. And right now you're probably thinking, wait a minute, how? How does the computer know not to just read from left to right like we do? What's the secret rule?
The secret is something called operator precedence. And this is gonna sound familiar to anyone who remembers PEMDAS, or Please Excuse My Dear Aunt Sally from math class. It's a strict built-in set of grammar rules that every computer on the planet follows to avoid confusion.
The rulebook is pretty simple. It says that multiplication and division are more important, so they always get done before addition and subtraction. That's why the computer looks at our problem and does the 2 times 4 part first, which is 8. Then it goes back and does the subtraction, 10 minus 8, which gives us the correct answer, 2. And there you have it. That's the whole journey. We went from a simple plus sign to storing a value to asking a true or false question, all the way up to a rulebook for logic. Every single app on your phone, no matter how complicated it seems, is built from these exact same, surprisingly simple pieces.
It's a pretty amazing idea when you think about it. All of the incredible digital complexity that surrounds us, it isn't magic. It's just layer after layer of these very basic, logical rules being followed perfectly millions of times every second.
So the next time you log in, or level up in a game, or just use any app, take a second and think about the invisible logic firing away behind the scenes. Now that you know the secret language of operators, you might just start to see these simple, powerful rules running everything around you.